Welcome to Wired Right.
Great to be here.
Today, we're diving deep into something really crucial for your home, but maybe something you don't think about much when you talk energy efficiency. I mean, your electrical wiring.
That's right.
We know Copperfield Electric. They're a family-owned 24-hour electrician license, hashtag 1094740, serving Orange County and all over Southern California. They see this all the time. People focus on smart gadgets, solar panels.
Yeah, all the visible stuff. But the actual pathways, the wires in your walls, they're the backbone. And they can seriously impact your energy use.
So true. We tend to fixate on how much power our fridge or TV uses, and yeah, that matters.
Of course. But the system delivering that power, the wiring itself, that can be a surprisingly big source of energy waste.
So our mission today is to unpack that, right? How your wiring might be costing you energy without you even realizing it.
Exactly. We want to show how just understanding this can help save energy. We're pulling from insights from pros like Copperfield Electric and also looking at some specific research on this wiring efficiency connection.
Okay, let's start at square one. Electricity comes into the house, hits the main panel, the big gray box usually.
The command center, basically.
Right. And from there, it spires out through all these wires to everything we plug in. Now, are those wires just perfect conduits, or is there, like, some loss along the way?
Oh, there's definitely loss. Think of it like water in a pipe. There's always some friction. For electricity, we call it resistance.
Okay.
Every wire resists the flow of electricity a little bit, and that resistance turns some of that electrical energy into heat.
Ah, heat. So that's energy that's not actually powering my lamp or my computer.
Precisely.
Yeah.
It's just wasted energy dissipated into your walls. And the thing is, the type of wire, how thick it is, the gauge, even how it's laid out, all of that affects how much resistance there is.
Wow. So it's not just the appliance's fault if my bill is high. Some energy might be getting lost just getting there.
It's definitely a factor, a hidden one, often.
So, okay, it's like a little energy tax taken out by the wires themselves. And I bet in older homes, that tax is higher.
You got it. Older homes, say pre-1950s, might still have what's called knob and tube wiring.
I've heard of that. Sounds old-timey.
It is.
Yeah.
And the big things are, it doesn't have a ground wire, which is a safety issue, and the insulation isn't great by today's standards.
So unsafe and inefficient.
Yep, both. The design, the insulation, it just leads to more energy loss compared to modern setups. You can see it reflected in your bills, even if you haven't added a ton of new gadgets.
And wasn't there an issue with aluminum wiring, too, maybe in the 60s and 70s?
Yes, absolutely. Aluminum was used for a while. The problem is, aluminum tends to corrode more easily than copper, especially where it connects to outlets or switches.
And corrosion means?
More resistance, like making that pipe rougher inside. So more energy loss is heat. Plus, those connections can loosen over time, creating hot spots, which is both inefficient and a fire hazard.
Okay, scary stuff. And what about just old thin wire? Not necessarily knob and tube or aluminum, just undersized.
That's another big one. Homes might have wiring that was perfectly fine 50 years ago, but it just wasn't designed for the sheer number of high-draw appliances we use today.
Like air conditioners, big fridges, electric kettles.
Exactly. Those thin wires struggle to carry the current. They heat up more. There's that resistance, again, wasting energy. And again, it increases the risk of fire. So if your wiring is undersized, you're literally paying for energy that's just turning into heat in your walls.
Right. So the wire material matters, the size matters. What about the coating around the wire, the insulation?
Hugely important. Insulation is what keeps the electricity flowing inside the wire, preventing it from leaking out. Think of it as the pipe itself, keeping the water contained.
Okay.
If that insulation gets old, cracked, brittle, maybe chewed on by pests or damaged by heat in an attic, electricity can leak. It's a direct energy waste, often completely invisible.
So good insulation basically keeps the power going where it's supposed to go.
It's exactly right. Good, intact insulation stops that leakage, prevents overheating, minimizing that heat loss we talked about, and it definitely improves safety. Less risk of fire or shock.
Makes sense.
And well-insulated wires last longer, stay efficient longer. So when you're doing any electrical work, making sure the insulation is right for the job, right for the load, is a really smart move for energy savings.
Gotcha. Now, something I think we've all done, plugging way too many things into one outlet or power strip.
Yeah.
Overloading a circuit, right?
Yeah, the classic overload. Happens all the time, especially in kitchens or home offices where you've got lots of devices.
So what's happening there from an efficiency standpoint?
Well, a couple of things. When a circuit's overloaded, all the devices plugged into it might struggle to get the power they need, forcing them to work harder and less efficiently. It can even cause those phantom loads where things use power even when off.
Okay.
And crucially, the wires in the wall, carrying that extra current, they heat up way more than they're designed to. And more heat means more wasted energy.
And that leads to the breaker tripping, right? That clicking sound from the panel.
Precisely. The breaker tripping is your safety net. It cuts the power before the wires overheat dangerously. But if your breakers are tripping frequently, that's a big red flag.
A sign that the system is stressed.
Totally stressed. It's telling you it can't handle your current energy demand. And every time it trips and you reset it, there's an interruption and often a bit of an inefficient power surge as everything tries to come back online at once. It's inconvenient, sure, but it's fundamentally a symptom of an inefficient, overloaded system.
So lots of trips to the breaker box means it's probably time to investigate the wiring. Okay, let's flip this around. What are the plus sides of a modern electrical system?
Oh, big advantages.
Mm-hmm.
Modern systems are just designed better for efficiency. For starters, we mostly use copper wiring now.
Which is better than aluminum.
Much better in terms of conductivity. It has lower resistance, so electricity flows more easily, with less energy lost as heat. It's just a smoother path for the power. And then there are the electrical codes. Modern codes are much stricter and specifically include rules aimed at energy efficiency.
Like what?
Like requiring thicker wires for certain circuits, ensuring proper grounding, planning circuits more logically to balance the load across the panel instead of putting everything on one or two circuits.
So it prevents those overload situations we just talked about.
Exactly. It's about smarter design, better materials like copper, better planning, and following these energy-conscious codes. It all adds up.
To lower bills, I assume?
Lower energy bills, definitely,
Yeah.
but also potentially fewer repairs down the line and maybe even longer life for your appliances because they're getting clean, stable power. It's a win-win-win.
Makes sense. Now, can you have new wires but still have an inefficient setup because of how they're run? Does the physical layout matter?
Oh, absolutely. You could have top-of-the-line copper wires, but if the layout is poor, say, the wires take a really long roundabout route to get to an outlet.
Like taking the scenic route instead of the highway.
Kinda, yeah. That extra length adds resistance. More resistance means more energy lost as heat along the way, even with good wire.
So the path itself matters.
It really does. Sometimes the problem is simply not enough outlets. People then rely heavily on extension cords, making the path even longer and often overloading to the original outlet.
Right.
Or having too many heavy draw appliances like the fridge and the microwave and the toaster oven all sharing the same circuit. It's inefficient.
So what's the fix? More direct routes.
Ideally, yes. Strategically adding more outlets can shorten runs. Creating dedicated circuits for things like refrigerators or AC units is a big help. And definitely avoiding daisy-chaining power strips off other power strips.
Yeah.
You want the power flow to be as direct and efficient as possible.
Okay. You mentioned codes helping efficiency. Can you give a few more specific examples? How do they force better energy use?
Sure. Modern codes often specify minimum wire thicknesses or gauges for different types of circuits to ensure they can handle the load without overheating. That's fundamental. They also require things like GFCI's ground fault circuit interrupters near water sources and AFCI's arc fault circuit interrupters in living areas. Now, their main job is safety, preventing shocks and fires.
Right.
But by preventing electrical faults, they indirectly stop situations that could waste energy or damage equipment, making it less efficient. Codes also cover things like tamper-resistant outlets, which are safer for kids, and even specifications for how electrical panels are designed for better load distribution.
So meeting code isn't just bureaucracy. It actually builds in efficiency.
It really does. It ensures the power gets where it needs to go safely and with minimal loss. If your system isn't up to current code, well, besides the potential safety issues, you could easily be paying more for electricity than you need to. Upgrading often pays off.
That's a strong argument for keeping things up to date. Now, this whole system is mostly hidden, behind walls, in the attic. How important is maintenance for keeping it efficient?
Crucial. Just like anything else in your home, the electrical system needs some attention. Over time, dust can build up in outlets or the panel. Pests might nibble on wires, or just normal wear and tear can degrade connections or insulation. All of that can increase resistance or cause small leaks, wasting energy.
So what kind of maintenance are we talking about?
Some simple things you can do yourself. Test your outlets periodically, especially GFCIs. Replace cords or switches if they look frayed or damaged. Don't ignore flickering lights.
Okay.
But it's also a few things come to mind. Switching to LED lighting is huge. LEDs use way less power, so they put less strain on your wiring overall.
Simple enough.
Installing surge protectors, maybe even a whole house one, can protect your electronics from spikes, which can sometimes damage them and make them less efficient over time.
Smart.
Using smart outlets is another good one. They can cut power completely to devices that draw phantom loads when they're turned off but still plugged in. Think TVs,
Like those
chargers.
sneaky energy vampires.
Right. And even just trying to schedule heavy appliance use, like laundry or running the dishwasher during off-peak electricity hours, can help balance the load on your system and potentially save on time of use rates.
But you need good wiring first, right?
That's the key caveat. All these tips work best when they're supported by a solid, safe, efficient wiring system. If the foundation is weak, these are just Band-Aids.
Makes total sense. So the big takeaway here really seems to be, don't ignore the hidden stuff. While we see the appliances, the lights, it's the wiring behind the scenes that could be quietly wasting a lot of energy if it's old, damaged, or just not up to the task anymore.
Couldn't have said it better. Just understanding how your wiring works and how it impacts efficiency gives you the power to make smarter choices. Upgrading or maintaining your system isn't just about flipping a switch. It's about lower bills, safer home, and getting the best performance from everything you plug in.
Absolutely. So if you're listening, maybe you live in an older home or you've noticed breakers tripping or your bills just seem high, it might really be worth getting your wiring checked out.
It's a smart move.
And Copperfield Electric, they actually specialize in electrical efficiency assessments. We really encourage you to think about getting a personalized evaluation. You can check out their website. They've got a contact form there, or just give them a call.
They serve homeowners and businesses all across Orange County, Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, Mission Viejo, pretty much everywhere down here.
Taking that step now, getting things checked, planning upgrades if needed, it really can lead to significant long-term savings and just a better, more efficient home overall.
For sure. Peace of mind, too.